Hello everyone, welcome back to ProjectPro YouTube channel. This is me Simran Anand, and today this video is going to be the part 3 of natural language processing tutorial. I hope you have watched my previous videos part 1 and part 2 wherein I discussed about the NLP techniques that you should be familiar with and how to effectively build ML models using natural language processing techniques for text classification tasks. I also discussed something about text similarity concept and word embeddings. So today's video is going to be super interesting application of natural language processing, which is question answer system. So I'm going to be explaining you what is question answering system and which how exactly you can build a machine learning model, an end-to-end system which actually answers questions and also does another task of NLP, which is next word prediction. So be it like you have a sentence with any mask tokens in it or any missing values, missing words. So your transformer or your model which you're building should actually be able to predict the word which can suit in that particular blank. That is the task we're performing, which is word prediction. So I'm going to build a model using transformers, which is pre-trained model, and then explain you the how you can deploy it using a web framework, which is FastAPI. Fast API is gaining momentum these days, and it's becoming really a very important and a very important skill for data scientists, especially because of the the lightweight framework, security, and many other features that it provides. And it's also faster and efficient. So I'm going to introduce you to Fast API and also demonstrate you how exactly you can deploy a machine learning model, which is in our case question answer system and next word prediction using Fast API. So let's begin. So if you observe that, when we talk about question answer systems in natural language processing or anything regarding when we talk about question answer systems, what exactly comes into your mind is that chatbots and virtual assistants are actually leveraging such interesting application. But have you thought of what exactly is question answer system and which models will actually perform better when and what models we should use in order to build a model, build a system which will actually be able to answer questions. So when you talk about question answer system, it's basically to automate the process of answering to questions given a context. So I'm going to explain you what is extractive question answering, where you have a document base or you have something called as a context. So given a context to a particular model, you have the model's responsibility is to find or extract the answer to your question, to the input question, by searching from the context it has the user has provided to the model. So that is how what is the meaning of extractive question answering. It's very interesting application of NLP. So in our use case today, I'm going to be explaining you that what how you can exactly build a extractive question answering system, and for that we are going to use pre-trained transformers. Now let me in since this video is going to focus more on the deployment aspect, how you can actually introduce you to Fast API and what in general is transformers and how you can actually deploy them using Fast API so that you can get an overall understanding of how to bring machine learning models to production level as well. So later, of course, after Fast API, because it's just an API endpoint, you can Dockerize it and then host it publicly using any cloud service providers like AWS, Heroku, and so on. So when we talk about question answer system over here, we are going to use both for question answering as well as next word prediction. I have made use of transformers. So basically coming to what exactly a transformer is. So if you refer to my previous videos of NLP, you must have, I was talking about the various, basically the recurrent neural networks. So traditional, when we talk about something called the traditional NLP architectures models, we know all about recurrent neural networks which operate on sequential information, and also LSTMs, which are long short term transform models. They are better in comparison to RNNs because of the long term dependencies, because of their nature to remember information from long term, because of that. But then even surpassing these two models, we can say BERT. When I say talk about BERT, BART, Distill BART, or all these, they're called as transformers. They come into category of NLP models called as transformers. Now, what is transformers? The advantages of transformers over traditional NLP models. For the demonstration purpose, I have used transformers. One reason being that it is pre-trained, they can easily be fine-tuned. Now, when I say pre-trained, transformer models are taken from Hugging Face. Let me just come and show to you an overview of the site. By the way, this is Hugging Face. You can go to the Hugging Face library and you can have a quick tour about what are the models and how exactly small snippets of code are there, how to load data sets from Hugging Face, and it can perform tasks like question answering. You can see a variety of tasks like be it next word prediction or any NLP task like summarization, See, these are all the tasks: summarization, translation, masked language tokens, etc. So all of them over here, you can find different transformer architectures as well, and some snippets of the code. So what transformer I'm going to take is also from same the Hugging Face library itself. So this particular package is, the transformer models are pre-trained on humongous and massive amounts of data. So it becomes very important for us to, very easier as well for us to fine tune it on any specific task of ours, because of their generalized nature, that they can even operate on any kind of context. You see, this is a context and it can again be fine tuned. You can change this context. I've given a random text over here which is talking about Delhi as a capital in India. So you can definitely change this context and give it any other context and ask a question which is going to, the answer should be in the context you have provided. So that is what we are going to talk about. So when I talk about transformers, the reason is because they are pre-trained and they give better accuracy, efficiency, and that is why they're giving, gaining momentum. But then the downside of transformers is that they, require computational resources and so on, and memory, and most of them also require GPU and such things. So when I say transformers, also, firstly, it saves time because they are faster, and the some of the features that I would emphasize on is because of they work on the encoder decoder architecture. Now, when I say encoder decoder architecture, you must be wondering what is this encoder decoder. So this is a, this is a basically the architecture of transformers. So they have two components, encoder and a decoder. Let us talk about a famous transformer which is BART, which has gained a lot of popularity and gives good results. Some just for your information, some of the other transformers are like T5 transformers, which are text to text transformers and so on. So when I talk about BART, it is, combination of encoder and decoder. The encoder leverages the bidirectional BERT model. Now, what is this BERT? BERT is bidirectional, bidirectional encoder representations of transformers, and the decoder aspect of BART transformer, it contains the GPT-2. So it acts, so basically BART acts as a denoising autoencoder. Now, these are heavy terms you must think, and they are buzzwords. So, bringing it down to a simplified way of explaining to you, I would say that the input is going to be a text. Any input sequence that is going to be passed into as an input to the encoder part. The role of the encoder is simply to, take the input text we have, and then convert it by doing feature representations. Give us a proper feature representation, which is going to be the word embedding of the input sequence. So there's going to be tokenization over here, because, when I talk about in my previous video, the first part, I have talked about what is tokenization. So each text we have input sequence is going to be broken down into separate components called as tokens. Tokens can be punctuation marks, characters, including all, any component of text. So that is going to be tokenized. So once you get the tokens from there, you're going to the encoder is going to apply positional encoding is going to be applied, and by using something called as a multi-head attention. So see, transformers are another advantage of that over the other traditional models is because of their self-attention mechanism. Now, when I talk about self-attention mechanism, is that if you've heard of the attention is all you need, the research paper published in 2017, which is attention is all you need, you would understand exactly what is this architecture talking about. But in a nutshell, I would like to, just give you an overview of why we are using transformers, the advantages. It leverages the self-attention layer where it focuses on the words. So it helps the transformers to actually, remember long-term dependencies in contrast to the traditional RNN models, which actually work on sequential information. This transformers actually be able to working on parallel, any kind of parallel processing of information can be done in case of transformers. So it need not wait for the previous input to, actually be processed and all. So that is one advantage of transformers. And so they work on self-attention mechanism, and the role of the encoder is to give us a feature representation or a word embedding from the input sequence. The output of the encoder is going to be passed in as the input to the second component of the transformer, which is called as a decoder. Decoder, if we talk in terms of BART, from the BERT, whatever the input is there from the encoder is going to be sent to the GPT-2, which acts as a auto encoder. So the role of that is going to be, it makes use of the masked multi head attention. Now I will explain you what is this masking concept and all. I will also with the demo. So for the decoder part is then going to give us an output, which is going to, after applying, at the last is going to apply softmax function, definitely logit function is going to be applied to give us the output probabilities. But what exactly is this decoder doing is that it's going to map the output of the encoder to a suitable target output. So if our case, for machine translation, that is nothing but, or any like language translation, or say even question answering, the answer is going to be something the answer to the question. So that is going to be mapped to the output from the encoder. That is the role of the decoder. So that was all about transformers, their advantages, which is long term, remembering long term dependencies, their self attention layer, parallel processing, and so on. That was why we are making use of transformer models. You can check out this blog on ProjectPro as well to delve deeper into why they perform better, the technologies which transformers are using, attention mechanism, why they are pre-trained, their performance, and so on. So that was all about transformers. Coming to the part where I was explaining that once you have the difference between transformers, LSTM, and RNNs. So we have here something called as a question answering. So if you see over here in question answering, let me explain you the code. From transformers import pipeline. So we are going to import pipeline because we need some encapsulation of all our methods, classes to be built, and then this pipeline is required because we're going to send a model for deployment. But in order to bring a model to the production level, we need to encapsulate all the methods and codes. So we are going to make use import pipeline from transformers, then class here. So you need to know a little bit of object-oriented programming here, which I've incorporated, which is I'm going to make use of classes and functions. That's it. And how exactly I'm going to call these functions classes by importing them in a separate another Python file, which is app.py, which is actually going to be deployed or run. So if you see here, this is class question answering. It has two functions. The init function is the default, like the constructor to initialize the parameters, then generate question answer, which is the function, and taking in the parameter as question. So this question is going to be the input question which the user is going to ask. So that is the input. So this can be when I'm actually running the application on fastapi, I'll be showing you whatever input we are going to give, that is going to be taken as input to this function. This function is basically going to be called or invoked. So we have something called as this pipeline, and the task should be mentioned here. So if you check out the Hugging Face official documentation, you will be understanding how exactly we can incorporate the code of building a pipeline and how to create a model using a pipeline. So we are building a question answering model. So that is why we are mentioning the question answering task over here into the pipeline. Now defining context for question. The context over here is about talking about Delhi being the capital, the components of Delhi, and something about when it was built, the year and the century. Passing question and context to model. Now we are passing in the question over here and the context, as you can see here, to model question answer, and then the answer is going to be retrieved. Now the answer can also be single worded or multi-worded. It need not be just one single word, it can also be multi-worded. Now that is all about a question answer system. We have just built this model. Now later I'm going to show you how we can deploy it in this. That's going to happen in this app.py file. By the way, this environment I'm using is VS Code, just for your information, because it's very much suited for all kind of any kind of web deployment, especially when you want to do, and also for Python, building Python models and so on. So I'm using VS Code over here. ID. So answer is going to, model answer at answer is going to return the answer. This function is going to return the answer, and that will be, retrieved by the API endpoint which we are going to build. Now, do not worry what is API endpoint and all. Let me, delve slowly into that. First, let me explain you now the next part of our model, which is next word. So our end-to-end system consists of two tasks, two applications of NLP, which is question answering and next word prediction. Next word prediction, for that I'm again using a transformer, which is happy transformer. It's just a variant of a transformer, and import happy word prediction. So a happy word is just again the name, but what we're going to do is we have something. If you see over here on my screen, artificial intelligence is going to mask the word. Now this particular token is called as a mask. So remember I was talking in the the encoder decoder architecture, I was talking about something called as a mask token or the masking concept. So masking over here is going to do nothing but to introduce noise into the input sequence. So since we know that transformers act as a denoising autoencoder, we need to introduce some kind of, the encoder has introduced some kind of a noise into the input sequence. So for that noise is going to be the mask token. Now masking is nothing but replacing something like fill in the blanks, I would say. So artificial intelligence is going to blank the word. There is a blank over here that the model is supposed to fill in. That's all about masking concept. So that is why we are making use of this mask token. You can also do, instead of, and that masking is going to be random. You can also do, if you're talking about how the model is going to add noise or introduce noise into the input sequence. You can also delete tokens, delete mask tokens and other combinations of noising schemes can be applied. But for this purpose, what we're going to do is the input is going to be the user has to especially give any sentence, but wherever there is a blank, there should be a mask present here, because this particular mask will be identified by our model, which is transformer model, and then be captured by it to understand that there should be some kind of a word to be filled in, and that particular word is going to be resulted by this transformer and sent to the API endpoint, which we're going to see on the web app deployed. Now, for next word prediction as well, I have the in parameter over here, the init parameter for initializing, and gen word, which is generate word. So text is going to be the the word, text is going to be the sentence which we are going to pass, the input sentence basically, and then calling in this happy word prediction and assigning it to this happy WB variable. Now, I'm just commented out this text because we are not, statically passing in information over here, but rather in contrast to the previous one where we have context is given by us over here. So if you tune this and give any other context, make sure that the input which you're passing in should have the question which corresponds to an answer which is present in the context you have provided. But unlike that, in next word, it's more generalized, because in next word prediction, what we're not going to set any text or any predefined text to operate on. The whatever the user is going to dynamically input, be it any sentence, any fill in, any sentence with any mask present over there, the mask token is going to be identified and predicted correctly by a model. Now, what we're going to have is the token is going to be predicted definitely by the model, but how many tokens are to be, like, what are the probabilities of words which can actually fill in? You want 3 words for the model to predict 2 most probable words, or 1 word, that can be set by this parameter called as top k, which you have to pass into this predict function. Now, text, you're going to pass in just 2 parameters, text, which the input text which the user has input, top k equal to 2. Now, top k equal to 2 is a number of probable words you want the model to actually come up with the most suitable ones. Now, along with this token, which is going to be the most popular token, a score is going to be assigned. Score is nothing but here the probability score of the token being correctly fitting into the sentence. Now, whichever token out of the 2 is going to be having a higher sentence score or higher probability score, that is going to be retrieved as one single answer by the model, and that is going to be assigned to res and passed into the app.py file, which we are going to which will be reflected in the front end of the web application. So this is all talking about the backend part. Now, now that you've understood this next word prediction task question answering, I hope I have made the concept of next word as well, very clear to you. It's again simply how transformers actually masking tokens to introduce noise into the data, encoding it, and again passing the encoded output to the decoder, which is encoded output is going to be the feature representation of the input sequence. So if you have this input sequence, something like a text, a sentence only, and that input sequence is going to be positional encoded. So basically, the transformer is going to not only focus attention is not going to be only given to that particular word. It's also looking at the context of the surrounding or the neighboring words. So the neighboring words are also going to be analyzed. That is the previous data, the previous words which come before the mask token and the words which come after the mask token. All of them are going to be analyzed. And depending on that, whichever is going to actually fit the context of the sentence is going to be retrieved by the model. Now, coming to app.py. By the way, requirements.txt, this is just the configuration of what all is required for building this application. You can just have a note, transformers and NLTK with all, these are just some of the dependency, the versions which you can install. So we need fast API, and fast API also talking about, now that we have understood question answer next word, let's talk about fast API. Fast API is basically, if you've heard of Flask, it's very similar to Flask, but it's, the reason why fast API is gaining popularity these days is because of the advantages it has. So we can say that fast API is modern, efficient, and it is lightweight as well. It's a lightweight web deployment framework. And the most beautiful part I found is that you did not, it has its own admin dashboard. So you do not actually need to build any backend dashboard or front end to display that. But fast API, it also, in contrast to Flask, Fast API has its own web interface, which is called a Swagger UI. So if you heard of Swagger UI, it was formerly called as Swagger UI, but now it's called as Open API. So Open API web interface to actually give a beautiful dashboard. Let me just show you how Fast API is. So if you see this official documentation of Fast API, do check out Fast API also to get an overview about what exactly is the framework all about we are using. So this is the code of how to take in Fast API. It has something called as endpoints. So how do we define API endpoints? API endpoints in context of any kind of web deployment you have two endpoints. The two basically you pass in a request and the model is going to give us a response. So for that you need to, using this decorator syntax of API, you're going to define the endpoints, which is for the both the response as well as the request model, and then pass in the parameters accordingly, and the return or the output as well as the input is going to be passed. The input also is going to be passed in the form of JSON object. JSON is JavaScript object notation that is going to be passed in, which is a key value pair, and the output is again going to be retrieved in the form of a key value pair. I'm going to show you exactly how that's going to happen. Now if you check out this Fast API, this is what I was talking about. This is the Swagger UI basically of Fast API. You can see how beautifully we are not even like actually built any or designed any kind of a front end for this. Fast API, it has its own has its own UI web interface, which is Swagger UI, and you can see this is the you can just passing in this local host dash docs. You can see the Fast API page over here, beautifully deployed, and these are the points. So get request, put request, post request can also be actually be checked over here. You can test your application using different tools, be it PyTest for checking your code test cases, and also Swagger UI is also can be used for testing purpose. Also, you can rely on the third party apps like Postman and so on. That was all about Fast API. You can check about Fast API also. So coming to okay, so this was all about it, and now Fast API coming to, just a small comparison I would like to give about Fast API and Flask is that Flask, it operates, if you've heard about the WSGI, which is Web Server Gateway Interface, but in contrast to that, Fast API, it operates on, or it handles ASGI, that is asynchronous server gateway interface. Now what is that asynchronous meaning? Asynchronous is that it can handle the API calls asynchronously. So unlike Flask, Fast API need not wait for the previous request to finish. It can so you can make advantage of something called as asynchronous call. So parallel processing can be done. That is why it's making Fast API very lightweight, efficient, modern framework, and definitely give it a go for deploying your web applications easily. And you can Dockerize it definitely after building this Fast API. You can Dockerize it and then host it publicly. Now, once it's done for this, you have this app.py file where we are actually, importing all these files, Q8 and next word, which we have built. We are passing in, generating the objects for those classes. Now, starting the app, as we have seen in the Fast API official documentation, this is how we start the app by calling this app object, app test, and we are using this decorator syntax. We have the get request and the post request. This is just for the demonstration test, for checking if the Fast API is actually running or not in our system. We have test pass over here for get request, and over here just a sample post request where you just pass in a text and the same text will going to be returned as JSON object by the Fast API call. Now coming to the actual model we have built, that is question answering and generate and predict next word. These two we have served as defined as API endpoints to the Fast API. And since Fast API uses ASGI, which is asynchronous server gateway interface, we are using words like async over here. If you see these, the keywords async def, before defining any function, we are calling, passing the defining it as async. And then passing in the parameter as text. Now text is going to be the question answering the question which the user has passed in, and this gen QA, which was the function we have seen in the QA class, is going to be called, and the answer is going to be retrieved by the the function, and that's going to be reflected in the Fast API. Now generate and predict next word as well. We are passing in the text, which is going to be a sentence with the mask token or a fill in the blank kind of thing, and gen word is the function which we have seen in the next word.py file, and then that function is going to be called by passing in this text parameter from the input. The predicate text is going to be just one, which is going to be the mask token, and that is, although we know that the function will return two locally. If you test the function, only the script, you will see that it's going to return two most probable words, because we have set top ks2, which is going to be two most probable words which are going to be retrieved as tokens. But then if you are setting in the over here in the fast API, the most probable word or the word having a higher score, higher probability score, the token having a higher score is going to be retrieved and sent to the fast API. Now to actually run this application, I've just made this main.py over here. Main.py to where we are calling in this, calling in the API app.py over here, and that is going to run on the local host. So let's run it. And firstly, you have to activate your environment. So since we have the QA, my environment is QA. I'm activating my environment over here in VS Code. Now this is how I activate my environment. Now once the environment activated, let's go to the cd into the change directory or into the QA is because the folder, the main.py, which we are going to run, is inside the QA folder. So go into that, and then just simply run this by writing python main.py. This is is encapsulating all your app.py code into this main.py. The reason, you can also run this app.py itself by simply calling in something called as a UVCon. UVCon server is used for running your fast API, for running your fast API apps. But then instead of running like using UVCon, if you've heard of Unicorn, especially for WSGI, when you're working with Flask, for fast API, we work with ASGI. So that is why UVCon is the command. But instead of using UVCon as an entry point in the running, I've just encapsulated the code into the main.py and into the main.py, and that is how we are calling it. So this is it's deployed over here, and it's saying that it's running in this folder, I think. Yeah, so it's running in this particular link. So let's just go to this link. Now you will see this was just for our demonstration case where I passed in. Now to get the Swagger UI, the beautiful part of fast API is that you can just write over here. You can make use of the Swagger UI, and this is the interface we have. So we have called in, this was just the default methods, get and the post method for just testing our application. The two which we have actually deployed our ML models. We have built two transformer models, right? Pre-trained models, which is question answering and generate and predict next word. Let us test question answering now. In order to test question answering, I'm just clicking on that execute function there, test function, and then pass any question answer. Now see, if you see, our context over there was Delhi, talking about all about Delhi. If you see over here in question answer, talking Delhi city and capital, let's frame any question like what is the capital of India. Now to check what is the capital of India, the answer should be Delhi. Let us see what is the capital of India. It's going to return a answer which is Delhi. It's going to be a single worded answer. Now, if you see, this is the answer response body, which is answer is Delhi. Now if you see here, the input is going to be a key value pair, which is JavaScript object notation, JSON form. Even the output was retrieved in the form of a JSON. Answer is in Delhi. Now, similarly, single word this was. Now, let us check if it can handle, it can even work on double worded or even multiple words answer. It can give us multi-worded answer. So let us say what are the components of Delhi, because that is one. We saw that there were two components of Delhi in the context which was given: Old Delhi and New Delhi. If you see my context, I have just passed in over here. It says it consists of two components: Old Delhi in the north, historic Delhi in the south. Let us see what this model will return. What are the components of Delhi? We're just passing in this question, and you will see the answer over here. Answer is Old Delhi in the north, the historic city, and New Delhi. So two components, Old Delhi and New Delhi, are returned by the model. So we can say that we have successfully deployed, this question answering system using fast API. Now coming to testing this endpoint where we are checking generate and predict next word. So try it out. And now this is basically next word prediction, where we have to pass in something like this. Like artificial intelligence going to mask the world. So similar, mask the world, it can be rule the world, change the world, conquer the world. But instead of, taking that pre-built sentence, let's give any other and test it out if our model is actually working on any generalized sentence. Let's say we just talk about NLP only. So NLP is a mask, we can say. It is a blank in our case, filling the blank to be filled. Mask of artificial intelligence. What is the proper word that this model is actually going to predict? Let us see that. Is a model be able to actually predict the word or not? The next word is going to analyze all these words. It's going to first analyze the words before mask, which is NLP, and the words after mask, which is artificial intelligence, and give us an answer. We will see over here, subset is the word. Now this is the correct way of, we can say subset. We can because definitely it will give two words. It can be subset also. It can also give us different words, but then the word having a higher score was retrieved by the model. The token having the higher higher word. So it can be even a subset or field of artificial intelligence. But the token which was having a higher score was retrieved by the AI, and the third part of the video, and that concludes the natural language processing tutorial. Do check out ProjectPro, because ProjectPro is a curated library of solved end-to-end project solutions. All projects are created by top industry experts working in the top global tech companies. And check out the ProjectPro YouTube channel. Stay tuned for more interesting videos and projects. Like, share, and subscribe. Thank you very much.